For a client in a multiplayer session to interact with an object that belongs to the server, it needs to send an RPC to the server to request this interaction, so that is what we will create in this video. But before we can do that, we need to finish our system to pick up objects from the map. In the previous video, we have created this pickable base script that contained a network variable m_isAvailable. It allows the server and all the clients to check if the object is available for pickup or if it is already in use by another client. With this script already implemented, we are going to right-click and create a new mono behavior. Let's call it PickableTool. And let's open it up. This script will inherit from pickable base. We are going to delete start and update. We need to right click on the name of the class quick actions and we can implement abstract methods. I want to show two different ways to remove objects from a map. When a client picks up an object, so an axe, it actually stays in the scene but becomes invisible with disable mesh renderer and the box collider. On the other hand, when we spawn a wood resource that appears in the scene, if I pick it up, we are going to actually remove it from the scene, because if we carry it to the drop point and place it, it actually is removed from the game map and added as a point towards the completion of this level. Now we do it this way because if we want to drop a tool and the tools are shared between all the clients, the tool that we drop will be teleported to a new position and re-enabled, so we can see it again and the mesh renderer and the box colliders are both enabled again. The alternative method is to despawn the object from our multiplayer session and actually destroy it from our scene. While each solution has its uses, in Unity we can't really, in a multiplayer session, just disable the object and be done with it, because the change is local. We would have to synchronize it with other clients. That is why Unity provides us with ComponentController component, which solves this by handling the synchronization of enabling and disabling components internally. So for our pickable tools that we just want to hide from the map, let's add a private component controller. Let's call it m_component_controller. Now we have our two abstract methods that we override. Apply availability state. This happens when the network variable is modified. So when we switch the tool to be not available for pickup, all we have to do is check if is server. Remember that the server controls this object. So if it is server, we are going to call m_component_controller.set enabled, and we are going to just pass the new value, so the value of our network variable. The downside of this solution is because the different thing might happen when we pick up the object. In this case, we are not going to have any code here, so no code. So when our client wants to drop the tool, we are going to just check if is server equals false. We are going to again return because the server owns this object, the tool. Now if this is a server, we are going to call transform.position, and we are going to assign it to a new vector 3. So let's assign it to new vector 3, and we are going to pass the position X and position Z, but we want to stick with the transform.position.y, so we want to keep the same Y position. And we are going to switch the m_isAvailable.value equals true, and this is the variable from our pickable base. We are switching this m_isAvailable value, and this in turn will actually trigger the apply availability state and re-enable the visuals and the box collider on this object, so this will happen automatically when we call this line. Okay, when we are ready, save the script. Let's go back to Unity. Let's go to our _network prefabs folder and find the axe and next pickaxe. So for the axe, we already have a mesh renderer, box collider, and selection outline scripts. Now we need to add a network object, because this object will participate in the multiplayer simulation. Now, to synchronize position, we have learned that we need to add a network transform. So let's search for it. And here I just want to synchronize the position. I want to keep the authority mode as server because the server owns this object, and I just want to teleport the object, so I do not need any interpolation. If I didn't uncheck it, the object would appear at the old position and slowly move towards the new one. Without it, it will just teleport. Next, let's add a component controller, and we are going to add two components here to our list. The first one will be the mesh renderer, and we want to disable it. And the next one will be box collider, and we want to disable it as well. They will start enabled so that we can see the axe tool when we load into the map, and the component controller, if modified, will automatically synchronize the new state if someone has already picked up the object for a late joining client. Okay, lastly, we are going to add our PickableTool script, and we need to assign the selection outline, the object type. Let's select from our list of enums axe, and the component controller, let's assign component controller. Next, select the pickaxe and apply the same components to it. So, network object, network transform that just synchronizes the position with no interpolation and the server authority, the component controller that will affect mesh renderer and the box collider of the pickaxe, and in the PickableTool script, assign the outline, set the object type to be pickaxe, and assign the component controller. To actually allow us to trigger the outline and later to pick up the object, we need to implement a script that will perform the cone of vision detection. So let's go to our _scripts folder, let's right click, create a new model behavior script, let's call it interactable detector. And let's open this script up. Okay, actually I think I wanted to name it or to call it interaction detector, so we can just change it. Now this will be actually a mono behavior because it will locally perform the detection. I want to remind you that each client and the server will reproduce each object, and each object will have the same scripts, and the only way to prevent those scripts to run on each machine is to check those isOwner, isServer flags. So in this script we can actually create our private bool m_isOwner and create a public void initialize method that takes a bool isOwner flag and assign it here. So m_isOwner equals isOwner. This is one way to save us from having to inherit from a network behavior in a script that does not necessarily need to synchronize anything else. What we want to do is create a sphere cast to detect all the objects that can be interacted with by the player. Next, we are going to define a cone of vision by defining the angle here, and we are going to check loop through each detected object and check if it is in the range of this detection. So check the angle between the forward direction and the direction to this object. If it is less or equal to half of the detection angle, and we are going to next, since we are going to discard this, we are going to next just detect the distance from the player to the object until we find the closest object to the player and select it as potential interactable object. Now this cone of detection system will be the same as you would create for a single player game. There will be nothing connected to the multiplayer besides this isOwner bool flag, so I will go a bit quicker here. Feel free to copy this script from our GitHub repository, but we are going to specify a private load detection radius and the detection angle, so the angle of the cone of vision, and we are going to get a half of it, and we need to have a layer mask pickup layer to define the layers that we will detect our interactable objects on. So we are going to save private iInteractable, that's why we have created this interface, as m_closest interactable, and we will create a property to return it so that other scripts can access it. Now, after we initialize this object, we are going to check in the update method. If m_isOwner is false, we are going to return to not run this code on objects owned by other clients or the server. And we are going to create a detect interactables method so that it can perform the detection. Here I will paste the detection logic. So we use overlap sphere to detect objects around the player. Next, we prepare our candidate IInteractable and detect a closest distance. And we loop through each collider, detecting if it is IInteractable object. And if it is, we detect the direction to it and check the angle against our detection angle, so if it is inside the cone of vision of our player. And next we check the distance to detect the closest interactable object. Now the only difference might be that we have our closest interactable toggle selection method, which toggles the outline. Now the additional if checks might be a bit redundant because I was fixing a bug and just added them so that it doesn't throw an error. But basically, if we detect the closest interactable and it is different than what we have selected previously, we are going to toggle off the selection on the previously detected object and turn it on the newly selected objects. When you're ready, let's save it and let's go back to Unity. We have a bit more work to do, so let's select our _network prefabs folder and open our player prefab. One of the child objects is called detector. So here we are going to add our interaction detector, and we need to assign the pickup layers, which will be our newly added outline and interactable layers. But before we can use it, we need to actually make the player aware of it, so we need to modify our player controller script. So let's select those three dots and edit the script. Great. We need to have a reference to our private interaction detector, m_interaction detector. I will make it into a serialized field so that we can initialize it. In a single-player game, we usually would use the start method, but in a multiplayer game where we inherit from network behavior, we need to override on network spawn method, and after the base on network spawn, we can call m_interaction detector.initialize is owner, so that we only run this code on the owner of this player controller object. In our game, when we perform the animation, we want to interact with the stone or whatever object that we have when the animation plays. So here we are playing the pickup interaction, and only when the character reaches with the hand, we are going to perform the picking up logic. So we want to integrate our logic with the animation events. In our project, we already have the animator and the animation event scripts. This is a helper script that will allow us to access the animation events. I have already prepared those for you, so let's just implement them into our own script. In our player controller script, we want to add a private animator, m_animator, and we want to again create a serialized field out of it. And we are going to add private animation events, and this is m_animation events. This is our helper script. Again, let's make it into a serialized field. We will also need private bool m_is interacting to store the state where we trigger the interaction. We do not want to trigger it again until the animation is done. When we have that, let's create on enable method and on disable. Because if you recall, in our my player input, we have defined on pickup pressed and on interact pressed. Those are events sent when we press the specific key. So we are going to go back to our player controller, and on enable, we are going to add m_my player input dot on pickup pressed. We are going to create some method like pickup pressed, so maybe it's called like this. And let's copy this because we want to add minus equals so that we unassign it in on disable method. Let's right click on it and generate this method so we do not have to type it by hand. Let me maybe rename it to handle pickup pressed. And inside this method, we need to first check if m is interacting. If this is true, we are going to return, because we do not want to trigger the animation again until the interaction is done, until the animation is done. Now next, we are going to check if our m_interaction detector dot closest interactable is equal to null. Because again, if we haven't detected anything, we can return. And next, we are going to call m_animator dot set bool with capital I interact and let's pass true. This is important because this is the name of our parameter in the animator. Lastly, we are going to assign m_isInteracting equals true. Because we have started the animation, we are going to leverage our animation events script that exposes onChop, onAnimationDone, and onInteract animation events so that we can listen to those. Now, to assign our listeners to those events, we need to go back to our onNetworkSpawn method, and we are going to check if isOwner. Now, isOwner, isServer, and the other bool flags will only be available when the object is spawned into the multiplayer simulation. So starting from this method, we can start accessing those, although the lifecycle and how the start, awake, and onNetworkSpawn are called depends on if the object is already in the scene or if we spawn it at runtime. But the rule of thumb is if you need to check isOwner, you want to do it in the onNetworkSpawn, and here you want to assign any events or event callbacks. So inside this if check, we are going to call m_animation events.onInteract, and we are going to add += handle interact action. So this is when the hand reaches towards the object. And we want to call m_animation events.onAnimationDone. This will be called for every animation in our setup, += handle animation done. Now for safety, we want to override the onNetworkDespawn method and basically do the same. So if this is owner, we want to unassign those callbacks to those events. Let's right click on those two and create new methods out of those. First of all, let's implement handle animation done, because all we have to do here is call m_isInteracting equals false, and this will be it. Now handle interact action will be a bit more complex. We want to check if m_interaction detector.closest interactable is pickable base. We are going to have different interactable objects later. If this is so, we are going to call request pickup server RPC. So here is where we are creating our RPC, and we are going to call the m_interaction detector .network object. As you recall, we can always access it, and we want to access the network object ID, so we need to call network object ID. Network objects have a specific property, network object ID, which is unique for each object and reproduced on each machine. So we can always verify or check or find the object using this ID. Okay, let's right click on this method and generate it. It will take long network object ID variable. So finally, we are going to create our first RPC. And to actually create or declare an RPC, it needs to have an attribute RPC sent to server or not server, where we can specify to whom this should be sent. And in addition to that, the name of the method needs to have an RPC suffix, otherwise you will see an error. So let's add at the top of this method the RPC sent to server attribute, and we already have the suffix in the name of the method. So what will happen here is the player object that is owned by the client will send a message to the same object reproduced on the server that it wants to request something. So basically, the script on the player object on the client's machine, the player controller script, will send a message to itself, but on the machine of a server, and this is basically what RPCs are. Back in our script, in this request pickup server RPC, we are going to perform a couple of checks. First, we need to check if this object actually exists. Since we are picking up a tool, it already should be in our scene. We are going to check if exclamation mark, so if not network manager. And to check if object exists, we can call spawn manager. Remember, we have access to the network manager because we are inheriting from network behavior .spawned objects, and we can use try_get_value method to try get the value with the network object ID, and we are going to assign it to the out network object target. the keyword out will assign the value if it exists to this target variable, and we can actually access it outside of this if statement. If not, this will return. So next we need to check if exclamation mark, so not target, dot try get component, and we need to check if this component actually has our pickable base. And actually we are not going to pass it here because we can pass out pickable base, pickable item. And again, this will assign this reference to this pickable item variable. If not, this will return. Next check, we need to check if we can pick it up. So if the exclamation mark, so not pickable item, can be picked up. So again, if it was already picked up by someone else, some other client, and only now we can call our pickable item.pickup method, and as you recall, it just called on pickup and set the m_is available.value to false on the pickable base script. It was a lot, so I hope we are done and we have created everything correctly. Let's save the script when you are done, or check it against the GitHub repository if you are confused about something. And when you're done, let's go back to Unity. Hopefully you are still inside the player prefab. We need to select our player object and expand the player controller, because we need to assign the interaction detector, which will be the detector, and the animator and animation events reference, which will be this character mesh object, child object of this player object. Let's exit the player prefab and we can try pressing play. Always start a host in the game view of the Unity editor and start client in the player 2 window. And if we start moving, you should see that the objects are highlighted. We should have probably implemented the camera follow script, but basically we can see that. And if we move our player 2, it will be highlighted on its screen, and the player 1, it can also highlight it, but if it walks away, the object stays highlighted in the player's 2 window. Just to see things better, that it works for both of those tools, you can see that the player 0 can select both of those. And now let's see what happens if I try to pick up maybe this pickaxe. Pressing E key, it disappears from both views. Maybe to see it later, let me select player 2, pick up the axe, and as you can see, it disappeared from both screens. But if you take a look at the hierarchy, it still is there, but the mesh renderer and the box collider are both disabled. In the next video, I will try to implement the camera follow script, and we are going to see how we can pick up the object and make it appear in the hand of the player that picked up this tool, so that we have this logic finished. Remember to like the video, subscribe to the channel, and I will see you in the next part.